Hey there! I'm so glad you stopped by the Take Moment channel. Our topic of discussion today is key computer components. Let's begin. Computers are impressive machines with several hardware components and subsystems. These work harmoniously to perform various tasks and execute programs. Whether you're using a desktop or laptop, you will find a variety of key components that make up these machines. Understanding the role each component plays helps you appreciate the power and efficiency of modern computers. Below are the key computer components. Number 1. The Central Processing Unit, or the CPU. Often called the computer brain, the CPU is the primary component responsible for executing instructions and calculations that make a computer functional. The CPU interprets and executes instructions from software and applications, performing arithmetic and logical operations, and managing data flow between different components. CPUs come in different configurations, each with varying speeds, number of cores, cache sizes, and power consumption. Remember, the CPU is one of the most crucial components of a computer, and its performance can significantly impact the overall speed and efficiency of the system. Number 2 is the Random Access Memory, or the RAM. The RAM is a key component of the computer's memory hierarchy. It provides fast and temporary storage for data that the CPU needs to access quickly during its operations. It stores data and program instructions that are actively in use by the computer at a given moment, enabling rapid read and write access. Unlike long-term storage devices such as hard drives or SSDs, RAM is volatile, meaning it loses its data when the computer is powered off. Its speed and capacity significantly impact a computer's overall performance, allowing for smooth multitasking, efficient program execution, and quick data retrieval. Remember, having more RAM does not necessarily make a computer faster, but it allows it to handle more tasks simultaneously without slowing down. The optimal amount of RAM depends on your tasks and software requirements you are using. Number 3. The motherboard. A motherboard, also known as the main board or logic board, is the central printed circuit board, or the PCB, in a computer. It serves as the primary hub connecting and facilitating communication between various hardware components. The motherboard houses the CPU socket, memory slots, expansion slots for graphic cards and other peripherals, and connectors for storage devices, ports, and power. The motherboard also includes a BIOS, or the UEFI firmware, that initializes the hardware during startup and provides a platform for running the computer's operating system. It acts as the backbone of a computer that dictates its compatibility with hardware components and plays a pivotal role in determining its overall performance and functionality. A graphics processing unit, or the GPU, is an electronic circuit intended to enhance and expedite image and video processing in a computer. Initially developed for rendering graphics in video games and multimedia applications, GPUs have evolved into highly parallel processors used for a wide range of other computationally intensive tasks, including scientific simulations, machine learning, and cryptocurrency mining. Notable GPU manufacturers include NVIDIA, AMD, and Intel. These companies produce various GPUs tailored to different applications, from consumer gaming GPUs to data center GPUs for AI and HPC workloads. The Power Supply Unit, or the PSU. The primary function of the PSU is to convert electrical energy from an external power source, for example a wall outlet or a battery, into the appropriate voltage, current, and frequency required to power and operate the device's internal components. Choosing a suitable power supply unit is crucial to ensure that a device or a computer system operates reliably and efficiently. It is essential to match the PSU's voltage, current, and wattage ratings to the power requirements of the components it will supply power to. Additionally, considering factors like efficiency, safety features, and form factors is important when selecting a power supply unit for a specific application. A cooling system is an integral part of a computer that helps to dissipate the heat generated by components like the CPU and GPU during operation. These components can become extremely hot, and without effective cooling, they may overheat, leading to reduced performance, system instability, and potentially permanent damage. Cooling systems typically employ various methods, including fans, heat sinks, and liquid cooling solutions. Fans circulate air to carry away heat, while heat sinks are metal components that absorb and dispense heat through their large surface area. Liquid cooling systems use a coolant to transfer heat away from the components more efficiently. Proper cooling is crucial to maintain the longevity and optimal performance of a computer system. Then we also have the input and output ports. Often abbreviated as I/O ports, are physical connectors on a computer that facilitate data exchange between the computer and its various peripherals. These ports are located on both the front and back of the computer and serve as interfaces for connecting devices like monitors, keyboards, mice, USB drives, printers, external hard drives, and more. The specific types and quantities of I/O ports can differ depending on the computer's make and model, but some common examples include USB ports used for connecting a wide range of devices, HDMI ports for video and audio output, Ethernet ports for network connectivity, and audio jacks for headphones and microphones. Accurately recognizing and utilizing these ports is essential for establishing connection and effectively using peripherals with a computer. A network interface card, often referred to as a network adapter, is a crucial hardware component that enables computers and devices to connect to networks. NICs serve as the bridge between a computer's internal data processing and the external network, facilitating data transmission by converting data into packets, handling addressing, and managing access to the network medium, whether through wired connections like Ethernet or wireless technologies like Wi-Fi. NICs can be integrated directly into a computer's motherboard or installed as expansion cards, and each NIC is assigned a unique media access control or MAC address for identification on the network. These components are fundamental to network communication, enabling devices to send and receive data within local area networks. That's the LANs and broader network infrastructures. Then we also have the expansion slots. Expansion slots are an integral part of the motherboard that allows users to expand and upgrade the functionality of their computer system. These slots provide a way to add hardware components such as graphics, network interface cards, sound cards, and other peripherals that might not be included in the original system. Expansion slots come in various sizes and types, including Peripheral Component Interconnect, that's the PCI, Peripheral Component Interconnect Express, PCIe, and Accelerated Graphics Port, AGP slots. They enable users to increase the processing power and performance of the computer system and add new features and capabilities to their machines. The BIOS or the UEFI chip is a crucial computer system component that contains firmware code permanently stored on the hardware. When the computer is powered on, the chip launches the boot process. It performs a series of checks and configurations to initialize the hardware components, such as the processor, memory, storage devices, and input or output interfaces. The firmware also provides a basic input-output system, that's the BIOS, or the Unified Extensible Firmware Interface, the UEFI, that acts as an interface between the operating system and the hardware, allowing the computer to communicate with various devices and perform functions like booting from a storage device or accessing the network. Without the BIOS or the UEFI chip, the computer will not be able to start up and run properly. The cables and connectors play a crucial role in linking the components of a system together, allowing them to communicate and share data. These cables and connectors come in various types and sizes, each designed for a specific purpose. For example, Ethernet cables connect computers and other devices to a network, while USB cables transfer data between devices such as smartphones and computers. The connectors, on the other hand, provide the physical interface between the cables and the devices they are connected to. By providing a secure and reliable connection, these cables and connectors ensure that the data is transmitted accurately and efficiently between the components of a system. These components work together under the control of an operating system such as Mac OS, Linux, or Windows to perform tasks, run applications, and provide a faster interface. The interaction of hardware and software allows computers to perform various tasks, from simple calculations to complex simulations and multimedia tasks. Thank you for watching this video. I hope you found it informative and enjoyable. If you have any questions or comments, please feel free to leave them in the comment section below. Remember to subscribe to this channel and hit the notification bell to stay up to date with all my latest content. I appreciate your support and look forward to seeing you soon.